Okay, so page 45, counting atoms. We're gonna fold this in half, and then if you'll take the folded line that you just made and trace down it with your pen, you should get a pretty straight line. I have done this 7 times, and this is the first time I made a mistake on camera. I'm nervous. So we've divided it in half. Okay, so the first thing you have to look for when you're trying to figure out the number of atoms in a molecular formula is to look for the chemical symbol. So an example of a chemical symbol would be Cu. This is the chemical symbol. And this just happens to be the chemical symbol for copper. The chemical symbol tells you what type of atom you have. So the chemical symbol is taken from the periodic table, and it tells you what type of atom you are working with. So this one is copper. Your chemical symbol can be 1 or 2 letters. Some are just 1, some are 2. If you have 2 letters, the first one must be capital. It must be a capital letter, no exception. The second one must be lowercase. You can think about it like a mama and a baby, or Batman and Robin. The big one's the one who's in charge. The little one is just tagging along. You can't ever have a little one by itself. It always goes with a big one. You have to have one big one, one little one. The second thing you're looking for when you're trying to figure out how many atoms there are is you're looking for the number beside the chemical symbol to tell you how many. So for this example, for example, CO2, the number here, that 2, is the subscript. The subscript. And what the subscript tells you, it tells how many of that type of atom you have. So this 2 is telling me I have 2 oxygens. You'll notice here, this C doesn't have a subscript. If we only have 1, we don't write a subscript. That would just be a lot of little ones. It would be too much work. It would be confusing. So if there is only 1, we don't use a subscript. So over here, this copper, it didn't have a subscript. So no subscript. Equals just 1 atom. So this is just 1 atom. It does not have any subscript. It's just 1 atom of copper. This has multiple atoms. It has a carbon, it has 2 oxygens. So this is a molecule. And what this represents, another way of thinking about it, if we have 1 carbon and 2 oxygens, this is the same thing as if we had it written out this way. So you can kind of think about it in expanded form. This means we literally have 2 oxygens, 1, 2, but we just combine them. It's like combining like terms, sort of, kind of. All right. So for this one, we have, so I said this subscript meant we had 1 atom. So here, this represents 1 atom of copper. On this side, we have 1 atom of carbon and 2 atoms of oxygen. That's what this represents. So far, so good? All right. We're going to draw a line across here to separate into our next 2 quadrants. And our next 2 things kind of up the complexity level a little bit. So these are the simplest cases. The next 2 are going to involve a little extra thinking. So I'm going to shift this up. I don't want to leave anybody behind. All right. So first we had an element with a chemical symbol. Then we had a subscript, which told us how many of that type of atom. The next thing we're going to have is groups. So our example of this is going to be Cu, open parentheses, OH, close parentheses, and then a 2. So everything in this parentheses is called a group. So this is an OH group. And what that's telling us is this molecule has 2 groups of OH and 1 copper. So you'll know you have a group when you see those parentheses show up. When you have these parentheses and you know it's a group, the subscript here beside the group tells you how many groups. So here the subscript is telling you how many groups you have. So is this telling me I have 2 groups? So this is the same as writing Cu, OH, OH. Again, we just combined the parts that were the same together. But it's still just 1 molecule. When you see this, when you're counting atoms, what you're going to have to do is multiply everything inside the parentheses by the number of groups that you have. So inside the group, you have 1 O, you're going to multiply that by 2. You have 1 H, you're going to multiply that by 2. This 2 goes to both of those things. So you will multiply everything in the group by the subscript. So you're going to multiply the group by the subscript. So for this particular example, we have 3 different types of atoms. We have copper, oxygen, and hydrogen. The copper is outside the group and only has no subscript, so we know it's 1 atom of copper. The oxygen is inside the group. So we have 1 oxygen in each group and 2 groups. 1 times 2 is 2. In the group, we have 1 hydrogen and 2 groups. So 2 groups, 1 is 2. The last thing we have to know, step 4 in the process, goes in this box over here, is the coefficient. That is a very mathy word. David, what if something is made of copper and oxygen, for example? So if it's copper and oxygen, you have Cu for copper and O for oxygen. You always use the letters you've got. You said AU, so if you were thinking gold, gold is AU. It'd be a capital A with a little u and then a capital O for oxygen. So let's look at the last thing we need, the coefficient. So here we've got a big number 4 in front of NH3. So this is called the coefficient. So this big number here in the front is the coefficient. And the coefficient tells how many molecules. So this is telling me I have 4 molecules of NH3. So that's the same as NH3, 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 NH3. I have 4 molecules of ammonia. So when you see a coefficient, you should be thinking molecules, plural. When you have a coefficient, that means you multiply everything, E-V-E-R-Y, capital everything, by the coefficient. Everything, no exceptions. So in this one, we have nitrogen and hydrogen. In 1 molecule of ammonia, we have 1 nitrogen, but we have 4 molecules. So we have to say 1 times 4 equals 4. So there are 4 N's. For hydrogen, 1 molecule of ammonia has 3 hydrogens, but we have 4 molecules. So we have 12 atoms of hydrogen. So it's basically a 4-step process. When you're counting atoms, first you have to identify the chemical symbol for the atom that you're looking for. Then you have to check, does that atom have any subscripts to figure out how many of that atom you have. Then you have to look and see, is it part of a group? If it's part of a group, then you have to multiply that by the subscript on the group. And then you have to ask, is there more than one molecule? If there is, you have to multiply that by the coefficient. Caroline said, why is the H capital if the second letter is lowercase? Can you give me a little bit more? Because I don't have an H with a second letter that's lowercase. Oh, this is not the second letter in the molecule. This is the second letter in the chemical symbol. So hydrogen has a 1-letter chemical symbol, so it's always the capital H. Nitrogen has a 1-letter chemical symbol, so it's the capital letter N. You only have a lowercase letter if the chemical symbol has 2 letters. So like copper is Cu, or sodium is Na, or gold is Au. If that symbol for one element has 2 letters, then the second letter is lowercase. All right. I know some of you have to go to football. I understand. I want us to look at some practice problems because I'm going to give you a little assignment that has some practice to make sure you know how to do this, but I want to give you a few problems to work together first, okay? So on your page, this was 45. You should have the page on the left blank. So over here, this should be page 44, if that's 45. And we're going to do some practice problems over here. So guys, I am recording this. So if you need to go and watch the last little bit later, you absolutely can. I understand. Some people have to travel. Okay. So practice problem number 1. If I were to give you 3H2O, could you figure out how many molecules this is, how many elements are represented, and how many atoms of each of those elements there are? So I want us to work the first one together. So hopefully we can go pretty quickly, but you'll understand. So molecules. What from our notes tells you the number of molecules? David, if you're struggling to see, you absolutely can always go and come back. Based on our notes, what tells you the number of molecules? Somebody. What tells the number of molecules?
The subscript.
Not the subscript. That tells you the number of that type of atom.
The coefficient.
Yes. So our coefficient is 3. So we have 3 molecules. When I ask you for the number of molecules, it will always be this number. When we're asking about the number of elements, we're looking for those capital letters because the capital letter signals new element. How many capital letters do I have?
2.
2. So, capital letters. One, 2. So that's how we got 2. Now, for atoms, we have hydrogen and we have oxygen. In 1 molecule of water, how many hydrogens do I have?
2.
2. And then how many molecules do I have?
3.
3. So I have 6 hydrogens in total. In 1 molecule of water, I have 1 oxygen and 3 molecules. So I have 3 oxygens total. Were you able to follow that pretty easily?
Yes.
All right, I'm gonna level it up. Are you ready for the level up? 2 Na3 PO4. And I'm gonna go ahead and give you the third one. And if we don't get finished with it before class is up, I'll post a picture of this so you can check your work. Is my screen still sharing? Okay, the green outline on my screen went away, so I was just double checking. How many molecules do I have here? 2, because it tells us right there.
2.
How many elements?
3.
3, because we have 3 capital letters. 1, 2, 3. So our atoms we're looking for are Na, P, and O. We'll go through and see how many there are in 1 molecule first. Sodium, in 1 molecule we have 3, P, 1, O, 4. We have 2 molecules. So 2 times 3 is 6, 2, and 8. Did you guys get that? Awesome. Before we have to go, work on this one. I will take a picture of the answer and share it with you so you can check your work. I am posting a small homeworky assignment on Google Classroom. It's a formative. It's gonna ask you to do this, but it's not gonna ask you to figure out all 3 of the atoms types. It's just gonna ask for 1. So it'll give you a molecule and then it'll just ask you how many sodiums. And I just want you to figure it out and you'll type just the number. You don't have to show me your multiplication. You just type the number and then it will automatically check for you and you can go back and work on any that you missed. It's just good practice to make sure you've got the skill. So as soon as I finish talking on here, I'm gonna go post that for you so you can do that. It's taken my on-site kids between 10 and 15 minutes. If it takes you longer than that, then send me a note because you're having a struggle and I will help you, okay? So you guys finish this. I am going to, Izzy, I'm gonna take a picture of these and post them So I'm going to go ahead and close it out so that I can go ahead and post the assignment for everybody. Anybody have a quick question before we go? Sorry, I start talking fast when we run out of time. All right, so I'm going to let you guys go. I will see you tomorrow. Look for the homework assignment, please.